Welcome to the BlameTheNetwork.com real-world networking video. Today we're going to cover troubleshooting network problems. Network problems may arise as total outages, maybe a device is down or a portion of the network is down, or it could be something along the lines of service degradation. Perhaps there's some latency with some of the services, or maybe a service isn't acting the way it's supposed to. So I'm going to jump into a little PowerPoint here and title slide. Alright. So process is key is the first main bullet slide here, and what I mean by process is key is regardless of what the issue is, you have to have a process flow for how you're going to troubleshoot the network. Keeping in mind that the issue may not even involve the network, as is the case oftentimes. It's just that the network is kind of unknown to a lot of others, to include the end users. So quite often the initial troubleshooting from an outage will occur when somebody asks, is the network down? And what they mean by is the network down could be a variety of things, but we're going to work through that with our process flow. So bullet point number one, gather as much information as possible. This is obviously crucial. You want to ask whoever the reporting user or technician is of the issue as much information as you can from them, because is the network down is not going to be a very good starting place for you to start troubleshooting. So obviously you want to ask them what exactly they're experiencing problems with, where the problems are occurring, and if there's multiple people that are affected by this outage. And in turn, you can turn their question of is the network down into a whole range of information that will allow you to start troubleshooting. Step number two, not really a step, but I guess bullet number two, and all these are going to kind of just take them all in and kind of formulate your own troubleshooting process for what works best for you. And the longer you deal with your network, the more comfortable and familiar you're going to be with it, and the quicker you're going to be able to diagnose where an issue is occurring with probably less and less information from the other side each time. So anyway, back to bullet number two, what changed? This should be the first question you ask. Now, perhaps the reporting user is not the correct person to ask, because it might just be an end user that has no idea about the IT infrastructure. Even more so, it may be another technical service personnel that has no idea of all the inner workings. So what you're going to do is possibly ask yourself what changed, because you might be aware of any outage windows for service that took place, or any scheduled tasks that maybe take place on the network or the servers. As well, you're going to want to ask the other IT sections. For example, whoever's in charge of running Active Directory or the servers or whatever you have in place at your organization, you're going to want to ask them if anything recently changed. The reason you're asking this question is because most of the time an outage or something, if something was working prior and all of a sudden is not working, something changed. Something took place that caused it to not work. So you're going to want to ask that question kind of to feed into bullet point number one of gathering as much information as possible. That's going to be one of the questions you're going to want to fire back or fire off to the appropriate individuals. Bullet point number three, notice outage commonalities. Now what I mean by commonalities is, let me go ahead and switch over to Big Bad Microsoft Paint. Pretty high tech, I know. So if, for example, this is your network topology, and you've got kind of your distribution layer, your core layer, kind of some routing going on, an edge firewall here, and your access layer down here that all your users hang off of at various locations. If there is a report, and then you've got your offsite locations up here that maybe VPN back into the corporate network, to include VPN users that are just accessing through the internet on their personal machine. So if you have a given scenario where all of the offsite offices can no longer connect and the VPN users as well are experiencing issues, then the common factors in that particular situation may be your own ISP connection may be having some difficulties. Even if you can still get out to the internet, if some of the protocols that are associated with whatever they're trying to do are being blocked or there's issues with it, then that could be a problem. Perhaps the firewall that these remote access sites are terminating into, maybe there's an issue with that as well, or there could be a number of other factors associated with the firewall in particular. But that kind of shows an example of looking at the common factors of an outage and kind of starting to dial in your troubleshooting into the given area that you think you should be working on. You're obviously not going to take a remote access issue and jump in and make sure that your switches have the VLANs going up to your distribution layer and checking your redundant gateways. You're going to start kind of closer to where the issue is, and that's kind of what you need to do when you're starting out troubleshooting, is jump closer to where the problem actually lies. Now, as you grow more familiar with your network, that's going to be easier to do. When you're first starting out, if you have to kind of walk it up the path, then that's understandable as well. Now, with that given remote access scenario, you're not going to probably walk it up from an access level all the way up until your remote access point. You're just going to start up there. But some other maybe some internal protocols, some routing issues, you may actually still, when you're starting out understanding your network, or just to take it step by step, you may actually start at your level and work your way up towards where the problem is. So that's an example of understanding outage commonalities. The next bullet point, actually the next two bullet points kind of go hand in hand, using the OSI model and walking your way through an outage. Now, I just kind of covered walking your way through an outage for the end of that last portion, but using the OSI model. So, for example, if user A down here reports that he's having some data connectivity issues, the first thing you're going to want to do is make sure that user A is able to check his computer and make sure he's got link light from his cable. If you have good documentation, or you know where he's plugged in, or if he has, for example, his MAC address readily available to be able to give it to you, and you can check the port on that switch, then that's great. You can do this step for him to an extent, but if he can tell you if there's link light or not, that's going to be the first step in letting you know if there's an issue down at the access layer, and kind of possibly the layer 1 as well. Now, obviously, if regardless of that answer, the cabling could be an issue as well. You want to make sure the RJ45s don't have a problem. If the cable's plugged in on both ends and your port is not shut down and there's still an issue, then if it's fiber or Cat5, you may have an issue with the layer 1. What you can do is, for troubleshooting at this kind of a level, you can remove some variables, right? So the end user's computer here, that is a very terribly drawn circle, but the end user's computer is a variable, right? So if you want to maybe take his Ethernet cable and move it over to a known working machine nearby, depending on your environment and if you're able to do this, or if you can take a laptop maybe that you know works fine, you can move his cable over to another machine, and if it works, then you know it was his machine. If the new computer that's known to be working still does not work on his cable, then there's definitely an issue kind of above his machine, if you're to look at this in kind of a hierarchy. So at that point, you would then go up to the actual port on the switch and make sure he's in the right VLANs, make sure his port's not shut down, make sure it's not error disabled from some sort of maybe port security or link flap or BPDU guard or anything like that. Look at the log, and then work your way up from there. Now, if the issue is isolated to this one workstation, then likely this is going to be where you stop. If it is a widespread issue, maybe multiple machines can't get to the internet or can't get to other resources on the network, then you're probably going to want to maybe even start one level higher. You may not work with individual users themselves. You may start looking at VLANs, traversing trunks on the actual devices themselves. You may look at if there's a redundant gateway protocol, you may look at that, or just make sure that the gateway is in an up status for that particular VLAN, depending on where you're doing your layer 3 SVIs at. And so you kind of just want to custom tailor, depending on what the outage involves, how widespread it is from a physical standpoint. You may want to kind of address your troubleshooting to that particular area and then walk your way up to the different protocols and different connections involved and kind of troubleshoot from there. So that's an example of kind of walking the problem. Moving on, adapt as you go. And I put CCNP troubleshoot here because that's kind of the best example that I can think of off the top of my head. So if we go to this picture here, this is the topology. If I'm not mistaken, as long as they didn't update the exam, which I don't remember, I think it's coming up for an update. The CCNP troubleshoot exam, which is one of 3 to earn your CCNP route and switch certification. The topology they actually put out there because they want you to know the technologies involved. They don't really care if you know the topology ahead of time. But this is a good example of adapting as you go, right? So I had fun with this exam of the three, because the other two, it's just a lot of multiple choice, and it gets really deep into some of the protocols and technologies. But with Troubleshoot, you kind of take all your knowledge from the prior two exams, assuming you did them in an order where it was the last exam, and you start using that knowledge to troubleshoot. So what I did, for example, a lot of the tickets were saying that client 1 here could not access the web server. So what I would do is jump on client 1 to a command prompt window and first verify that they weren't lying to me in the ticket there, and then from there I would do a trace route to the IP address of the web server. And typically what this is going to do is I'm going to start seeing different hops in the path, and I'll be able to identify, based off where it stops, roughly where the issue is occurring. So as far as adapting, say it made it past the distribution switch and it made it to router 4, and then it would stop R4 here. I can see that based off this topology, and if this were my real world network, then I would kind of know what protocols or technologies were involved. When I say technologies, I mean like this routing protocol, EIGRP, this one OSPF, DHCP server that's supplying IP addresses, etc. So if it stopped at router 4, that I would know that right away there could possibly be an issue with route redistribution between OSPF and EIGRP. Now, if other machines can still get to the web server, then that might not be the case, but this kind of puts you in the ballpark of the area of where you might find an issue. And it might not always be right at that device if a packet stops there. And also keep in mind that packets don't always get replies from certain devices. Firewalls are notorious for just not replying at all, because it's kind of a security thing to an extent. But it's going to kind of put you in the right area roughly. So that is not only a strategy you can use on your CCNP troubleshooting, but it's also a strategy for general network troubleshooting overall. Let's jump back over here. And the last bullet point, use tools at your disposal. And I did not cover that at all on this slide, because this next slide here, titled Batman Utility Belt, because it seems like Batman always has a tool for every problem that shows up. And in the same sense, network engineers should have tools at their disposal for any troubleshooting scenario that they encounter. So the first kind of half of this slide covers actual outages. So say you have a router down, a particular section of the network down, and you've confirmed this, then what you need is kind of a understanding of what's taking place and what's connected to what. So network maps and topologies are good, and when I say that, I mean maybe a Visio diagram or even something drawn up on a piece of paper is fine. Anything's better than not having anything at all to understand what's going on. Obviously having updated information is good, because if you're looking at a very old, outdated map that has changed, then you may end up troubleshooting things that don't exist. But it's good to have network maps and topologies kind of stored locally or somewhere you can get to. And the reason for that as well is because the next bullet point there covers network monitoring solutions. But if you have a total network outage, maybe from a power loss that did not restore properly, then you may not have access to your network monitoring solution. So it's good to either memorize, although we can't trust our memory with as much information that gets tossed at us in the IT world. It's good to have maps and topologies and Visio documents that you can get to locally in case that sort of situation arises. Now, moving on to the next bullet point, the network monitoring solution that I just mentioned may be of absolute no use to you if you have a power outage. Assuming you can get to it, then it is a wealth of knowledge for you, because it's going to be able to show you what's up and down. I've actually got an example of What's Up Gold. So this is What's Up Gold. It's one network monitoring solution, and there's obviously many out there. SolarWinds, Observium, OpenNMS, I believe is one. I might have just made that up just now, but anyway, there's a whole range of them, free and open source as well as commercial solutions. And the general idea behind them is to show you, typically most of them have maps on them, so you can see a red-green status of all your devices and segments and services provided. And quite often they have additional capabilities as well, so it's kind of your one-stop shop for network management from almost always a web interface. And so some of the additional features that they might have is syslog, daemon or syslog server, so they have the ability to take syslog messages and display them to you in a central area, so you can break it down based off device or maybe level of syslog message, so critical or emergency or whatever. And they probably also, well, not all of them, but some of them have NetFlow collector capabilities where they can analyze flow statistics and data, which I'm going to get to in a minute. And quite a few of them, or almost all of them I should say rather, have timestamps and historical data on when a device was down, or maybe previous issues, so you can see if there's kind of an issue that's happening around the same time every week, and then you can determine maybe somebody's flicking the power switch when they head out at the end of the day, or just information that'll kind of help pinpoint you in the right direction. So having a good network management, or rather network monitoring solution, is definitely key to good troubleshooting. Ping and trace route, as old school as it may seem, ping and trace route are probably never going to die, and are also possibly some of the best troubleshooting tools you have at your disposal. With an initial outage, obviously using a trace route to a known IP address is going to kind of help you identify if there's any breakdowns along the way in the path. Keeping in mind what I said earlier about not all devices respond to ping, but this should show you the hops along the way and if it kind of dies off anywhere, as well as being able to ping a device will tell you, how you're doing as far as connectivity. Now, the other caveat to those tools is that they use the ICMP protocol, which is port 7, I believe, and that protocol is obviously unique. It's its own protocol. So if there's an issue with maybe SSL port 443, geez, brain fell apart there. So if there's an issue with SSL, then obviously a ping is going to tell you, overall network connectivity, but it's not going to tell you if there's maybe a firewall blocking port 80, port 25, port 21, name your common service ports. As well, it's not going to tell you if there's any issues with the actual service being provided. So if the server, maybe a service stopped on the server, so now you can't get to TFTP or SMTP or something, a ping is not going to tell you that. Ping's just going to tell you if whatever you're trying to hit is alive, assuming it responds back. But not to undermine those tools, because they are definitely very helpful in troubleshooting your path. So let's go back over to Paint for a second. So obviously, if I had an issue with a machine, getting to a specific resource, maybe there is a server switch here, and there is a ESX server here, and on that ESX server is a VM for, that's a terrible example, I don't know, DNS. Alright, let's use that as a example. So there's a DNS VM. So what I'm going to do from the machine itself is, and this is kind of asynchronous from identifying how large the scope of the problem is. Obviously, if every machine can't get to DNS, all of a sudden can't resolve host names, then I know it's basically an issue with the service, or a firewall port all of a sudden, or ACL started restricting it because there's no firewall in the path here. But what I'm going to do from the machine is, and these are probably access layer switches, so they probably do not have any routed SVIs or any sort of IP address other than management. I'm probably going to ping up to my default gateway, which is likely actually going to be kind of a redundant gateway protocol, HSRP, GBLP, VRRP, one of those, where both of these switches act as one device and share an IP address, which there's another video on if you want to check that out. I'm going to ping up there. Alright, if I can hit that, that's my first hop, then that's cool. Then what I'm going to do is whatever these virtual servers are using for a gateway, it's probably going to be located on this server switch. I'm going to see if I can ping there. And if I can ping there, then that'll tell me a couple things. First of all, if I can hit the gateway, I should be able to hit the server, right? And then if I can hit the gateway, let's do it another way. If I cannot hit the gateway, say I can hit my gateway, and then I time out after that, that tells me that I need to start looking at the two devices that are acting as my gateway and determining if there's an issue with routing, maybe a routing protocol between these two, maybe static routes. Perhaps there's an issue with the actual ether channel going between those two switches right there. Perhaps there's an issue with, it could be a variety of different problems that could occur on the network, but you kind of have isolated at that point a general idea of where the problem is taking place, and you can kind of work from there, along with other troubleshooting steps at the same time. So, obviously if other machines can hit that gateway and my machine can't, well, that's kind of strange. Are we in the same VLAN? If we are, I mean, is there, at that point it'd be very strange, is there an ACL block on my particular IP, or, so you kind of get the idea that you start pinging and working your way out from where you're at, or where the problem is, and towards the other end of what you're trying to see. I'm going to jump back over here. If there's a problem reported that's not a total outage, not a router being down or a network segment being down, so say you get an email or a phone call that says there is latency on the network, network is slow, that sort of thing. There's some additional tools. Not to say that the prior tools won't assist you in this, but other than ping and traceroute, the maps and topologies in the network monitor, they're just going to still show everything as being green, probably. Now they may show you bandwidth utilization, some other things, but for the most part, they're not going to flip over and start throwing bells and whistles like they would if there was a total outage. So, your additional tools that you have at your disposal is number one, a NetFlow collector, which you want to get set up if you don't have a good one already in use. And I'll show an example of a NetFlow collector. So this one is an example on PRTG, and you can see the top talkers on the network, top connections, top protocols, and what this is going to allow you to do is, for example, if there's latency on the network, or there's latency, let's say someone called and said, loading YouTube is slow. Well, first you need to ask them why they're trying to load YouTube at work, but second, what you want to do is look at NetFlow statistics from your edge router, maybe your DMARC before it goes to your ISP. And the NetFlow statistics are going to show you if there's a particular protocol that's eating all your bandwidth. For example, you can see right here, www is eating 84% of my bandwidth here. And then there's not really much else going on the network, but there's, along with the protocol, you'd then be able to see who the top talkers were that were utilizing all the bandwidth. Now, alright, I had to do a quick administrative cut. Now, more than likely, web is not going to be the main bandwidth hog there, but if it were maybe a streaming video service in high resolution and maybe everybody's trying to access it at once, perhaps the Olympic Games are on, or some big football game and everybody's at work but they're trying to watch it, then you likely could see that as a top protocol. But whatever you end up finding, that'll allow you to start using quality of service or shaping and kind of give some bandwidth limitations for that particular protocol or for a specific user perhaps, and that will allow you to give the network some more breathing room. Now, a lot of those kind of things, if you run into them a lot, are going to become management type decisions as far as what is allowed in the network, what isn't, and different things along those lines. But from a general troubleshooting standpoint, NetFlow is going to give you some good metrics to be able to use and troubleshoot what's the problem with any sort of latency or any sort of slowness on the network. Logging information is going to be helpful if there is a problem reported and it involves only an isolated area. Perhaps maybe you jump into a switch and find that there's fans dying on a switch, so that's why it's behaving abnormally. Those kind of emergency and critical logs that pop up are good signs that something bad is about to happen if it's not already happening. So logging is a good way for you to have another tool at your disposal to see what has been going on in the past. Definitely log to a centralized server if you're not already doing so, because if your devices reboot, their local buffer is going to get flushed. So they're pretty much worthless for historical data at that point. So if you're not logging to a centralized server already, then you are wrong and you should probably fix that. I guess unless you don't use logging at all, but definitely a useful tool to have. Packet capture being the last one I've listed, and there's probably more that I don't have on here. And but with packet capture, packet capture is kind of a love-hate relationship. You really get down to kind of a granular level when you get into packet capture. So when you get to, let me see if I can bring one up real quick. Alright, I got one up here. So when you get to this level, right, and this is Wireshark, so I just want to bring this up for anyone who's not familiar with packet capture already. You are essentially looking at a packet by packet basis of any sort of network communications and network connection. Now, you'd have to set this up one of a couple ways. You'd either have to have a machine that is running a packet capture utility and then have kind of a span port going to it. Or you could do an embedded iOS packet capture on one of your devices on your router, and I have another video tutorial on that if you want to set one of those up and check it out. It's actually pretty slick. But you need to first isolate what you're trying to troubleshoot, which is kind of tricky in packet capturing because you're seeing thousands and thousands of packets fly by. So unless you can set a good filter, or on the embedded iOS capture you can do an ACL to kind of specify which traffic you want to see, it's going to take you a little bit of time, first of all, to identify the traffic. Now once you identify it, you may not really understand what you're looking at right away. And there's a lot of tutorials and a lot of books on how to read packet captures, and so you kind of are starting to get the idea of how granular this can get. Not to undermine its capabilities as a good troubleshooting tool, because if you get to that point where you can't find anything wrong with any other tools at your disposal, but there's definitely an issue going on and nobody's been able to resolve it, packet capturing may kind of set you over the edge on finding what the problem is. But it could be something as simple as a window size issue, maybe with packet fragmentation, but you might not notice that from looking at these packets. So you can already see how it's going to be some work. You're going to have to put in some time and effort into looking at these packets, but definitely another tool that you should have on your tool belt there to be able to troubleshoot from a packet level. So that's all I got for you for now. Definitely make sure that you've got a good process flow for troubleshooting network problems. You don't want to jump around from device to device without really knowing what's going on. And again, your flow will kind of improve and build itself as you get more familiar with the given network that you're working on. So the longer you work with it, the more familiar you become, the more efficient you're going to be at troubleshooting. But definitely keep some of these tools and some of these kind of tricks in mind when doing some network troubleshooting, and hopefully it'll help increase your response time and resolve any issues if there are any, or prove that it's not the network if that's the case, which quite often can be. So thanks for watching, and look forward to more videos here coming soon.